Farmers gather from all over the country. They scoop boiled rice into sacks made for carrying onions and into cedar boxes. It is now March, a time when they should be preparing for the busy farm work that lies ahead. But instead, they are taking the rice to the mountains. They stop within a field of bamboo. After digging softly with their hose, they bury the bags and boxes of boiled rice they brought to this place. They are meticulous in this task, as if burying some kind of treasure. They cover the buried rice with paper and allow space for air to enter. The process resembles a secret ritual. Some of the ground is covered with rice. A snowy pathway of rice materializes amidst the bamboo. Finally, they seal the site with a blanket of fallen leaves. It is now a secret shared only between the farmers and the soil. In the city, height is what matters most for plants. Poking up through the earth, plants grow vertically, going ever upward. For most humans, it would be no great inconvenience to live without any patch of dirt nearby. But elsewhere, there are people living a slower-paced existence who use the earth to make clothing. It's as if the soil's unique hues possess a secret. Some people apply earth to skin disorders, such as eczema. Healing comes after a matter of days, thanks to the almost mysterious properties of the soil. The earth is even used as a vessel. Soil has no specific form, but it can transform itself into thousands of different shapes, depending on the person whose hands are molding it. Creating form out of something shapeless. This is an essential property of Earth. This time it's being plastered on a wall. Soil is worn, eaten, and slept on. It is involved in every aspect of human existence, even though it barely gains notice. That is the nature of soil. A long time has passed since humans first began coexisting with the soil. The earth is a wonderfully selfless being, offering fruit in exchange for mere seeds. Other creatures know this quite well. This wasp, grappling with the soil, is creating the building blocks for its nest. In spring, the swallows, too, are more intent on building homes than on finding food. The fight for useful earth becomes a subtle competition. The humanid wasp builds its house in the shape of a pipe. Its amazing skill of using its own saliva to plaster soil is a wonder to behold. The swallows put together their nests with a variety of materials, such as straw or dry plant roots. After just 3 or 4 days, construction is complete. The black-capped kingfishers build their nest inside an earthen cliff. She has just hidden its most precious treasure beneath this soil. An entire brood is carefully concealed by this wall of earth. But the many ways the soil can be manipulated are much greater than this. Look just below where our feet meet the ground, and you will find a whole new, unexpected world. A brightly hued female tiger beetle is picking a fight with a hapless earthworm. The male tiger beetle, however, is only thinking about mating. After mating, the female uses her backside to dig about 1 centimeter into the soil, where she lays her eggs. The soil has now become a womb, harboring a life 2.5 millimeters in diameter. Beneath the soil's surface is a refuge for tiny creatures that use the earth as a shelter to ward off predators and as a home to raise their young. Over 150,000 lives can be found in just 1 square meter of soil, including insect eggs, larvae, and adults. Among the more than 1 million species of insects, 95% spend at least part of their lives living in the soil. An earthworm emerges from an egg sac that resembles an orange grain of rice. Though the earthworm is yellow now, it will take on a reddish appearance as it absorbs oxidized iron from the soil. This creature will spend its entire life crawling through the soil. "10 days later, the eggs laid by the tiger beetle begin to quiver. Compared with its body, its head is enormous. As if by instinct, it begins digging a vertical tunnel upward. Its own head serves as a weapon. After drawing its prey into its tunnel home, the tiger beetle holds onto it with its big jaw. Below this large rock, even in a small space where fallen leaves don't reach, there are many tiny holes. A battle is in full swing here, too. A series of attacks come in rapid succession. Paralyzed by the hidden predator's stings, the hapless ant slips into the soft sand. The winner of this fight is an antlion or doodlebug, which is equipped with a sharp and powerful jaw. Its entire body acts like a radar system. It is highly sensitive. The antlion digs a funnel-shaped sand trap in dry, crumbly soil found in the shade. The trap is set in just 15 minutes. He has created a frightening netherworld for other insects. Insects passing by stop paying attention at their own peril. Up in the air, however, a different kind of battle is unfolding. With energy amounting to 4.7 kilocalories per gram, trees mark their territory with an array of fallen leaves. Trees shield their roots from snow and rain with a layer of leaves that also prevents the soil from washing away. And the roots absorb energy from the fallen leaves after the foliage decomposes on the ground. No harsh sunlight, plenty of moisture, and an abundance of food. Below the blanket of fallen leaves is a haven for tiny insects. A millipede, with a pair of legs for almost every segment of its long body, feeds on dead plant material here. This creature, with the wide, golden-colored body, is a free-living flatworm, which can only live in areas of high moisture. It oozes a mucus trail, which it uses to glide slowly over the rough soil. Gastropods, such as snails, also like this kind of dark and damp place. This creature moves by sliding across the mucus it secretes from its muscular foot. Using its radula, a tongue-like organ that also acts as teeth, there's nothing this creature cannot eat, from moss and decaying leaves to the base of tree trunks. This is also the home to creatures that thrive on mold, bacteria, and algae. They include tiny, wingless insects called springtails, plus mites less than half a centimeter long. Food at every turn with the table already set. Their only job is to clean up these morsels. Thanks to this behavior, the soil becomes lighter, allowing for faster circulation of its nutrients. We catch a glimpse of a pair of pincers. This tiny creature, only 3 millimeters in length, is a pseudoscorpion. A mite just 1 millimeter in length. The pseudoscorpion chases it with its pincers poised for action. The predator's hunt ends in success. These are the lives of the tiniest creatures we can see. Many humans live their lives without a thought to the world measured in millimeters. There are some creatures that spend almost their entire lives within the soil. In a damp area beneath the roots of a tree, a cicada is living out the larva phase of its life cycle. A long white body. This is the larva of a white-spotted flower beetle. It's been half a year since its birth, so this is a crucial time for the creature. 1 month spent as a pupa in a cocoon. It endures the throes of rebirth to emerge as a fully grown adult white-spotted flower beetle. Its black wings and white spots are distinctive. When it gains enough strength, it is ready for the world outside. Three seasons spent in the ground. But in the end, the white-spotted flower beetle escapes the grip of gravity and reaches the surface. An earth-dwelling mole cricket. This creature's habitat is primarily underground. Of course, it is an excellent tunnel digger. Just at that moment, an ant attacks. The cricket is quickly disabled by a shot of a sticky secretion. Up and down, to and fro, the mole cricket's movement digs up a bunch of soil in its wake. This path acts as a pathway for rainwater. It also becomes home to mold, germs, and smaller insects. Laying eggs, hatching, feeding, hunting. Virtually every key event in the life of a mole cricket takes place underground. Thanks to the mole cricket's subterranean habitat, the soil can breathe. A mound of soil is neatly erected, almost like a wall. Judging from the shape of these blocks, the creature who did this must have a long body. The owner of this structure probably lives nearby. Ah, it's an earthworm. The tower is actually made from this creature's excrement. A tower made of soil with building blocks each about the size of a bean. This is a natural fortress which is usually not washed away by the rain, nor is it easily surmounted by predators. Here and there it deposits huge stacks, making sure that the entrance is closed when it finally goes back underground. The amount this creature eats is enormous. Each day it devours an amount equal to its own weight. Decayed plants like these are its favorite. Earthworms are often said to feed on soil, but it's actually the organic matter that it's after. Fallen leaves are food that cannot be disregarded. Nibble by nibble, with a firm grip between the lower lip and the palate, it cleans up the area around its home. Its excrement ends up being full of nutrients. That's why soil where earthworms are abundant ends up being fertile land full of nutrients. On a small scale, this creature is as strong as Hercules. It digs and burrows, pushing its way through soil 50 times heavier than its own weight. This pathway provides drainage for water, ventilation for airflow, and a passage for growing roots to follow. Short, thorn-like bristles, called setae, provide support and traction for the body when it moves upward and around. The earthworm's body contains a long digestive tract. It is the home to many microorganisms, which multiply when rough earth makes its way through the digestive system. The soil that is excreted by the earthworm is coated with these microorganisms. The large agricultural implements of humans cannot easily dig more than 30 centimeters beneath the soil, but earthworms routinely dig a meter deep, sometimes 3 meters when it's time to hibernate. Indeed, earthworms may be the best digging tool in the animal kingdom, including humans. This creature is rather conspicuous above the surface, even though it spends most of the time underground. Judging by all this movement, it might be a rather large creature. A mole on the prowl. The high-protein earthworm is a favorite food of the mole. After ripping apart the earthworm's head, the mole devours the earthworm's nourishing body. As many as 10 earthworms might make a meal. Thanks to its rudimentary eyes, it's almost blind, but its highly developed nose allows it to detect food 5 centimeters deep in the soil. It's rare to see exposed soil in nature. Whether covered with leaves or grass or adorned with flowers, it's usually adorned with something. How does the soil manage to dress itself up like that? To know the secret of the soil, we have to look beneath the earth. Perhaps we need some help from science to see what is going on inside the soil. After diluting soil with distilled water to 1/1000th its normal density, we place 1 drop onto a culture medium in a Petri dish. It's only a drop, but it's an entire world beyond our imagination. These vigorously growing creatures are bacteria. More than 5,000 species live in 1 teaspoon's worth. A population of over 100 million microscopic creatures. They continuously search for a decent place to live with the right balance of oxygen and temperature. Soil is the ideal home for a multitude of bacteria. They eat here and propagate here. This is 1/5000th of a centimeter. In a size too small for humans to truly grasp, bacteria cling to the soil and live as part of it. This organism feeds on phosphoric acid. In soil with an overabundance of this chemical, this bacteria is essential for reducing its presence. an invaluable resident in land that has been treated with high amounts of phosphate-containing fertilizer. Bacteria have no teeth, so they dissolve their food using enzymes secreted by their bodies. The absorption process is similar in principle to a sponge soaking up water. Bacteria's survival strategy relies on numbers rather than size. The quicker ones can divide every 18 minutes, multiplying in rapid succession. With the right combination of food availability, temperature, and humidity, they could cover the entire planet in just 2 days. A power of reproduction that is indeed amazing. After the rain falls, the mountains emit the odor of soil. This is because of a substance called geosmin that is emitted by the actinomyces. Reproduction occurs through spores like this. Many microorganisms thrive under damp, fallen leaves. These whitish organisms are called Hyphae. They are a mass of filamentous fungi. Viewed individually, of course, they are very tiny. Filamentous fungi, or mold, extend slender threads called hyphae, which take in carbohydrates and protein from dead animals and plants. The process is similar to that found in the digestive tracts of animals. Even the most complex compounds can be broken down into simple elements. These creatures are among the most efficient cleaners on the planet. At the vigorous rate they multiply, these molds could cover a surface measuring 500 million square kilometers. The spores come in a variety of colors. This is clear evidence that they include quite a few species. These microorganisms also wage war. Two different species encounter each other as they spread. They can grow no more, can they? Antagonism, the interference in the chemical processes of another microorganism, is what keeps their growth in check. This is a key reason why pathogenic microbes cannot grow too fast. Another thing that keeps them in check is that there are creatures that consume these soil-bound fungi. These creatures, wiggling around like earthworms, are eel worms, a kind of nematode. They look a lot like thin, transparent threads. An eelworm pierces a hole in a hyphae with its syringe-shaped mouth and sips the carbohydrates, protein, and lipids inside. Molds can bring disease to plants, but for pathogenic fungi, the eelworms are a frightening predator. Sometimes, though, the tables are turned and the mold preys on the eelworms. The eelworm is trapped in a loop made by a group of fungi. The inevitable result is falling prey to the mold. One can see a trap made by the mold using their own bodies. Once something becomes entangled here, there is no escape from this sticky substance. If these creatures did not feed on one another, the world would be quickly flooded by mold. At first glance, the soil appears to be a quiet domain, but upon a closer look, we see it is clearly a world where billions of creatures wage war on each other. Thanks to fungi, every creature that once had life will eventually return to its original elements. Like a sponge, organism-rich soil doesn't collapse even when humans tramp across it. If we look closely, we see that the mold Hyphae hold the grains of soil together like so many springs. It is thanks to these microorganisms that soil does not blow away like dust. There must be a reason every plant takes root in soil. Just as leaves reach out for sunlight, roots extend into the soil in search of nutrients. Through cooperation between leaves and roots, plants are able to grow. A root will fork and multiply seemingly endlessly in search of adequate oxygen, moisture, and nutrients to sustain the plant. 1 meter beneath the ground, it digs deeper and deeper inside and makes a new path in the soil. When it finds a promising spot, it sprouts root hairs that can interact with their surroundings. Water and nutrients pass through these delicate pathways. They provide a whole new environment for the microorganisms living in the surrounding soil. Water is pulled up through the roots and synthesized with air and sunlight in the chloroplasts to make plant sugars known as saccharides. Some of the plant sugars produced this way are sent back down to the roots. About half of the plant sugars that are produced are sent down to the roots. Numerous microorganisms swarm the root to feast on the saccharides. There are creatures in this underworld that will never see the light of day. Instead, they meet the sun through plant roots. In return, they provide the roots with over 20 inorganic nutrients. The microorganisms follow their lead. This is the realm of the root. Soil barren of plants usually contains few microorganisms. The two go together like needle and thread. One such microorganism is the bead-shaped fungus found in mycorrhizae. This fungus reaches into narrow cracks and crevices where roots cannot reach, gathering nutrients in return for the saccharides from the plant. In relatively barren soil, it can increase a plant's rate of nutrient absorption by 2,000 times. Mycorrhizae extend hyphae and live among the root cells. Because of this, the plant can gain another 30 centimeters of root growth. Pine trees can take root even in barren soil. This is thanks to a fungus known as the pine mushroom. This fungus densely surrounds the roots of the pine tree, thus expanding the surface area of the roots. The power of these regulators is what gives birth to life in the soil. Despite their microscopic size, they affect the entire planet. These simple symbiotic relationships have brought into existence far more complicated ones. Lives that inextricably interconnect with one another. That is the nature of nature. Fruit as well are an integral part of many plant relationships. Clematis berries, raspberries, wild grapes, Chinese gooseberry, and wild ginseng. Nature lets us know that she hides precious things within the earth. Humans clear the land for a greater harvest. When the soil is depleted, humans treat it with chemical fertilizers and spray pesticides. For microscopic creatures, with at most a 20-hour life cycle, such activity is like a nuclear explosion. Once these tiny creatures are killed, the soil is like a wasteland, an empty nest with only the shells of once vibrant microorganisms. The farmers visit the bamboo forest again after 1 week. The buried rice really has become a buried treasure. It is again a teeming ecosystem inhabited by billions of microorganisms. Microorganisms living on the bamboo roots have migrated onto the rice intact and ready to thrive. What might have been sustenance for the humans has become sustenance for these microscopic creatures. These farmers need these native microorganisms in their primordial state. When mixed together with sugar, the microorganisms cease activity and become dormant for a while. Once the rice is brought to the fields, the farmers mix it with water. The microorganisms are reactivated. This rice is spread on the fields instead of chemical fertilizers. The microscopic workings of the soil have been brought back to life. In just 3 short days, the microorganisms have dominated the soil. These creatures keep each other in check, making sure that there is no more growth than necessary, which helps keep the soil alive. Thanks to their help, seeds are able to grow and thrive. Farmers elsewhere are spreading a fermented mixture of soil and rice instead of fertilizer. In a sense, the farmers have become stewards of the microorganisms. The microorganisms, in turn, help raise the crops. This orchard is thick with weeds. Ironically, though, the field's yield has increased. Eating, being eaten, interacting, and competing. That is the natural order of things here. This fruit is like a condensation of every life that ever existed on this patch of farmland. This fruit is a witness for those humans who want to know what truly happens within the soil. Farmers who know the secret of the soil bury rice in the earth again.